Okay, welcome to this unit for System Analysis and Development. So in this unit we're going to look at lots of different things to do with creating information systems, more so the theoretical side of it rather than the actual development. So what is an information system? An information system is a system, a set of components which make up a system which humans can interact with. So it can be hardware, it can be software, it can be a combination of both. In most cases, it's a combination of both in these sort of times. When you're creating an information system, you need to make sure that the software you create can run. So in order for it to run, you need to also have hardware as well as your software. So an information system exists to turn raw data into information. So with information systems, there's a set of components making up the system, and these people, equipment, procedures and data all work together with a common goal of providing reliable and accurate information. Information systems can be manual, or they can also be logical as well, computerized. So when we get into the analysis side of the scenarios, you'll find that some of the procedures we're running through are physical procedures. It's someone handing someone an invoice rather than an email being sent or data being sent through a logical or computerized system. We need project managers to manage IT projects to make sure that they run within the budget constraints, to make sure that the project and the company has a positive cash flow. So if we don't have project managers, projects often run over budget and over time. Project managers also ensure that the functionality which is outlined by the systems analyst meets the end user's requirement. So the user will often say, I want a system that does this, this and this. We need to make sure that the system at the end, when it's handed over in the implementation phase, actually meets that requirements. So we talk about the system development lifecycle later on. We talk about the evaluation and maintenance stage. So in that stage is where the project manager and systems analyst will look at what the user requirements were, and they'll evaluate whether they actually met those requirements and whether that system can then be maintained. So there's different roles within the development process. We've got the project manager, as I mentioned before, who's responsible for the planning and executing and closing of the projects. They also make Gantt charts and PERT charts, which analyse the production time and how long each task will take. With the systems analyst, who is generally a consultant who works externally, and they look at the actual system and the operations. They collect all the data about the existing systems, whether it's physical or logical, and then develops context and DFDs and ERD diagrams so that the developers can then take over and test and write and create these programs based on these specifications. And we also have designers who are responsible for the graphical user interface, or the GUI. So that's a very important stage. We need to make sure that the system is intuitive in the way that it works and responds, and there's a flow between the different screens. Project managers have different methodologies to ensure that the project runs on budget and stays within the scope of the project to avoid scope creep. There's a number of different methodologies which we'll focus on. There's the rapid application development, which is designed to make sure that the application gets put into the prototyping stage as quickly as possible. There's waterfall and cascading models, which we'll go over very quickly later on. And we've got the system development lifecycle, which we'll be spending a lot of time on over the next couple of weeks, which is the main methodology which we focus on. So these are the tools that tools or methodologies that the project manager can use in order to ensure that the project is on track. So the system development lifecycle is a methodology for designing and building information systems, and there's 6 main phases. There's preliminary analysis, which is basically making sure that the project is feasible and that it can actually go forward. If it doesn't get past this stage, then the project is canned and it won't continue at all. But the analysis stage, where we look at the existing procedures and processes of the existing system to make sure that they collect all the relevant information about the existing procedures, so that we can then design the system in the next stage. We then have the development stage, where the programs take over and take all that information and build the actual system. We have the implementation phase, where the system's actually put live And then we have the evaluation and maintenance phase, which I mentioned before, which is where we evaluate to make sure that the user requirements are implemented. When we're modelling information systems, a model describes the information system as how it will be implemented by the user. It's a graphic form, so it's how the system will be built. It will show how the end users interact with the system. So there's again multiple different tools, different diagrams that we use to describe these, which we'll go through in a moment. There's physical and logical systems. As I mentioned before, information systems can be physical and they can also be logical. Often in the scenarios which we'll go through, we're merging from a physical system to a logical system. So a physical model describes how the job is going to be done. It concentrates on the physical comments. So as I mentioned before, handing something over, inputting data, processing information, those sort of things. Logical model is more abstract. It's looking at what the system highlights and the content which is being processed through the system. So logical aspects can be the same as the physical. It can be done on pen and paper, but often it's done by the computers. So logical model does not tell us how things are done or by whom. It just shows the process and the inputs and the outputs into the system. So later on, when we do these context diagrams, we talk about sources and sinks. So the source of the information, the sink is where the information goes eventually. So as I mentioned, there's different types of modelling tools. We've got context diagrams, which define the boundary or the scope of the project and the physical interactions with that. So there's external entities, which are the sources and the sinks of the information, which process and push information into our information system. We've got data flow diagrams, which look at the new system and the logical flow of information throughout the system. So we break down that major process, the boundary of the system. We look at the internal systems. So it's at stage 3 computer science, we actually look at level 1 DFD. So we move from the level 0 and we break down those individual processes further. A data dictionary describes the data which is going to be put into our data stores. So it's basically data about data. And that's a common definition you'll have for data dictionaries. Data dictionaries are data about data. Entity relationship diagrams are the graphical representation for entities or tables within a database. So it talks about the relationship between data and how that is utilised. And then flowcharts finally are the models of the logic of an algorithm. So we'll look at modelling different algorithms, including loops and different things like that when we get into programming. As I mentioned before, all information systems need to have some sort of hardware which they're operating on. And as you know from previous studies in computer science, all software must run on an operating system. So be that Windows, be it Unix-based, be it Linux-based, whatever that system is, and that system then runs on hardware. So you need to understand the hardware side so that you know what your system is capable of running on. So for example, if you're running an information system which is built for an Android operating system, you'll be programming in a certain language, you'll be looking at memory allocation based on the current handsets, etc. And then you need to ensure that when the system is implemented, it's implemented on the correct hardware. So when we're developing information systems, we have to be aware of the current trends of hardware and software and ensure that we develop the software efficiently and for the software to be supported ongoing. So we'll also need to look at disaster recovery in the case that there's any physical or virtual threats to our systems. And we'll also look at cloud solutions. So cloud solutions are a current trend in computer science at the moment, whereby we store information in off-site locations on the internet rather than within the actual company. We also have to look at the ethical issues. So the main ethical issues in developing information systems is the secure disposal of data. So for example, if you have an online shopping cart that you've implemented and you're storing everyone's credit card details to process transactions, you need to make sure that that data is disposed of securely. So you need to make sure that no one can go through your trash and find out that information. We also have to see the roles of ethics and laws with this, and making sure that when we're using a marketing system to send emails, that we're doing that ethically. We make sure that if we're storing any credit card details for one-click payments, that we need to make sure that those are stored securely, and that we use those appropriately, legally and both ethically.